Hello, everybody, and welcome to lesson 6.2 on similar polygons. And this is on page 348 in your textbook. So let's underline similar polygons title. Similar means the shape is not exactly the same, but it looks similar. That's the word. Polygons are many-sided closed figures. Like a triangle is the smallest one. The symbol for similar is a little tilde. This is called a tilde. And this means similar. So the other one was congruent. Do you remember that one, congruent? So we are not talking about congruency, but we're talking today about similar. All right. So this was earlier. Okay, so what we're learning today is how to identify and apply similar polygons. Similar figures have the same shape. So let's read this and underline it so you know that you need to come back to it. Have the same shape, but not necessarily the same size. They could be the same size actually, but usually they're not. You can abbreviate is similar to with the symbol, this didn't download, tilde with this symbol, okay? Essential understanding, you can use ratios. Ratios are fractions and proportions. Proportions are two equal fractions. To decide whether two polygons are similar and to find unknown side length of similar figures. So we're going to write ratios and proportions today and solve them for unknown quantity by using cross product. The cross product means you cross multiply to find the unknown quantity. I'll say cross product. Product means multiplying. And when we write our ratios and proportion, order matters. That's important. You cannot mix and match. That's the most important part, how you write your proportion, okay? So let's look at the key concept. Always make sure you have something to highlight or underline. Key concept, similar polygons. Here's a definition. Two polygons, these are the polygons, are similar if corresponding angles are congruent. In other words, the angles are the same. So you have to have each angle matching in size. That's the first thing. Corresponding, remember the word corresponding means the angles are in the same location on each shape. So you're looking, how does the shape look? Like this angle, it corresponds to this angle, this one to this one because it has one bow. These two correspond because they have the two bows. And this is this one as well because they're the right angles and they're in the same location. So this is the first criteria. The angles must be congruent or equal. So I'm going to write that up here. Congruent. But the second criteria is that the length of the corresponding sides are proportional. In other words, the ratios are equal or same. So angles are congruent, side length form equal ratios. Okay, now here's something how to write it. The angles that are corresponding is written like that. These are angles. And the sides are these, and this is called an extended proportion because you got each side, like side AB, this side corresponds to GH, to this side, And that should be equal to BC, this side, divided by HI, this side, and so forth. I don't have to name it all. There's 4 sides, so there's 4 ratios. And if you divide these numbers, there's going to be a decimal, and those decimals need to match. So these ratios have to be the same. In other words, when you divide or reduce your fraction, the number will be the same. Okay, now here it's talking about extended proportion. This is what that is. It's not just 2 proportions, it's in this case 4. It depends. Why are there 4? Oh, it's just giving you an example. It's the same one here. You see how this one matches this one, extended proportion. And now it's talking about a scale factor. A scale factor is the ratio of corresponding linear measurements, so it's side lengths. So we're not talking about angles. So you always keep it straight. Are we talking about angles or sides? So scale factor is always talking about the sides because linear measurements mean sides. Okay, of 2 similar figures. So the figures have to be similar for the scale factor to be true. The ratio of the length of corresponding sides is more simply stated the ratio of corresponding, okay, forget all this mumbo jumbo, look at it this way right here. This little part is important. Let's look over at our 2 triangles. By the way, the triangles are similar. It tells us that because of this symbol here. You see the statement, super important. 20/8 is the same as 5/2. This is the ratio 20/8, and it reduces to 5/2 because you're dividing top and bottom by 4. So you want to reduce your ratios and they should match. If I take any one of these side lengths and I reduce the ratio, it'll always come out to 5/2, which is the scale factor. 5/2, you can write it as a fraction, or sometimes you see it with a colon. And when you divide the 2 numbers, use your calculator if you have to, but some of you might know 5 divided by 2 is 2.5. So what that means is that the bigger triangle is 2.5 times the size of the smaller one. And that's the scale factor. Times the size of the smaller one. Okay, so this is important information here about how to write. By the way, if you start writing your proportion, if you start with the smaller triangle and then go to the bigger one, to write the second one, you have to go back to the smaller one, over the bigger one, and so on and so forth. You cannot go from the smaller one to the bigger one, and then from the bigger one to the smaller. That would be mixing and matching. This is what I'm talking about when I wrote order matters. So you got to go back to the original shape and write your next ratio. Okay, and I'll show you what that means. We're going to page 349, and I'm skipping problem 1A because the pairs of congruent angles are easy to identify. You just go to the look. By the way, my similar symbol did not download again. This is what that means. This is a quadrilateral because it has 4 angles, 4 corners. D goes with H, E goes with J, F goes with K, G goes with L. You're just matching up the letters for angles. These are the angles, okay? But we are going to write the extended proportion for the ratios of the lengths of corresponding sides. So you're matching up the letters again. So remember, it's a quadrilateral, so side DE. So I'm starting out with the first one, DE over HJ is equal to, now I'm going back to the first one. That's where I started. EF, I cannot mix and match over JK equals FG over JKL. And then there's one more, you go first and last, DG over HL. So that's called extended proportion. And these are the corresponding sides. And then it says here, how can you use the similarity statement, which is this one? This is your similarities or similarity statement to write ratios of corresponding sides. What can we say? I just think it's easiest to say match up the letters. So when you have this statement, it's easy to say which ones are the corresponding parts. Okay, so on this page, we're done. That was page 349. We're moving on to 350. And let's go to the top. Determining similarity. We're going to decide, see, they're not in this question, they're asking, are the polygons similar? They're not telling us. If you look at the previous page, it was given that the polygons were similar. You see, they already told us they're similar. What are the parts that are going together, right? Now they're saying, are they similar? Not quite clear. If yes, write the similarity statement and give the scale factor. How do you identify corresponding sides? They're not giving us that similarity statement, so you kind of have to look, match shorter and longer sides, because there's two shorter and two longer. It's a rectangle. So I'm just going to go from, I'll start with the first one, and I'm going to write my first ratio. It looks like, because this is short and this is short, that 10, this side goes with the 15. Actually, I'm going to leave myself room. There's going to be some information here. So I'll start over here. And then that should equal, then I'm going back to the original one, and I'm looking for the long side, 15. Then I'm jumping to this one, the long side is 20. And I have to decide if this proportion has equal ratios. The ratios should be equal. So there's 3 ways to test that. I'm going to write down all 3 of them, and you can decide. This is not an extended ratio because you only got 2. So if you have 2 ratios, which is a normal proportion, excuse me, there's 3 ways to test. You can reduce the fractions and see if they match. Or you can divide using your calculator, top by bottom, and see if, and that's going to be a decimal. And then you compare, are they matching or not? Or you can do the cross product and see if the numbers match. If they match, it's similar. So these are your choices. Do one of these, okay? Which one you please? I'm going to show you all 3. So I'm going to start up here. 10 over 15 is equal to 15 over 20. And when you reduce, it's turning into a divide by 5. So that's 2 dividing by 5 is third. 15 over 20, I can also divide by 5. So that's 3 over 4. That doesn't match. So therefore, I already know they're not similar. But this is the first way, reduce the fraction. The second way, divide. So you use your calculator, need a calculator, and you go 10 divided by 15. So that's 0.66. Repeating does not equal 15 divided by 20. 0.75. So that doesn't match either. So that they're not similar. Cross product is when you do 10 over 15 equals, I'm just rewriting it. The cross product means you multiply across. 10 times 20 is 200. 15 times 15 is 225. They don't match. So in each, I only showed you the 3 cases so you can pick which one you like. However, if the first one fails, you don't have to do any more. The answer is no, because it says, are they similar? No, they're not. So you're already done. Okay. So now let's go down to the bottom and let's try number 3. Same thing, it's asking, determine whether they are similar. So your answer should be yes or no. Yeah, determine. If so, write a similarity statement and give the scale factor. If not, explain. But I can already tell you they will be. So just to show you why. So I'm looking for the corresponding parts, right? If I have 3 sides, I have to make sure all 3 ratios are the same number or value, okay? So just 2 sides will not work. The reason I chose 2 sides here is because we're having a rectangle and both sides are equal, right? That would be 15 as well, and that would be 10 as well. 20 and 20. So then in that case, I only have to write one proportion like that. But now we have more numbers and I need to make sure all 3 side proportion ratios match. So I'm going to start and I'm going to write down that KJ just to show you where I come up with this matches PQ. These 2 sides are the same. How do I know? Right angle, 1 bow, right angle, 1 bow. Those are the clues I'm looking for. And that has to equal JL, if they are similar, RP. That's called the extended ratio. And KL, I'm looking for the sides that match up. Okay. And remember, I started with the first big one, so I go to the smaller one, then I go back to the big one over the smaller one, back to the big one over the smaller one. So now let's try the numbers. K, that's 16, PQ is 8, equals JL is 30, RP is 15, and that should equal KL is 34, and the other one is 17. Notice that the bigger triangle is always twice as much. The numbers are exactly, so this, yes. So my conclusion, so this turns out to be 2, and this turns out to be 2, and this turns out to be 2. Use your calculator and divide. 16 divided by 8 is 2, 30 divided by 15 is 2, 34 divided by 17 is 2 as well. So my conclusion is ratios are equal. Each fraction has the same value. So the 2 triangles are similar. So I'm using symbols to shorten it, but now it says So if so, write a similarity statement. So a similarity statement looks like that. I'm starting with the first triangle. I'll call it triangle anywhere you want. I'll call it KJL. Any is similar. And then when you go to the second triangle, you have to start with the same. So it's Q matches K, P matches J. You need to match up the angles. This is called a similarity statement. Okay, similarity statement. So yes, they're similar. Here's my similarity statement and give the scale factor. Scale factor is 2. This is the number here. Which means the bigger triangle is twice the size of the smaller triangle. So how did I get the scale factor? I divided. If it's not coming out to be clearly 2, you could say, you could reduce your fraction and say it's 2 to 3, or it depends. I'll show you. Hopefully we'll come across one when it's not exactly a whole number. Now, if I had compared the smaller triangle over the bigger triangle, if I had written this and started with PQ on top and KJ on the bottom, I can do that. The scale factor would be 1/2. And that would just mean that the smaller triangle is half the size of the bigger triangle. So depending how you name your ratios, which number you put on top, which you put on the bottom, that's how your scale factor is going to turn out. Yeah. Now look at number 4. We already can tell that these two are not similar. Why? Because the angles are not equal. They have to be equal. Remember on the first page, it told us that not similar. Because angles are not congruent. Okay, so yep, nope, no on that one. Okay, let's move on. Next page is page 351. Let me do the question on top. Use the diagram, and it says using similar polygons. So notice that they're already telling us the polygons are similar. So we don't have to prove it. It's giving us the statement so you know which side lengths are corresponding. So that's an easier one. This is always good to have, this statement here. It says, what is the value of y? This side length here. So notice you have a big quadrilateral, this one, and you have a small one inside. And that's what they're saying. These two are similar. Okay. All right, so let's see. We need to, first of all, order matters. I'm going to put that on top. Always don't forget, wherever you start writing your ratio, you got to come back to that one. And we're going to write a proportion and solve with y in it. So one of the spaces will have a y. And then we have to solve that proportion. Okay, so let's see. AB, this side, and that's 5, correct? Tells me here 5. And EF are corresponding. So I'm going to EF, that's this side. So that's called a Y. And that should equal, now I have to think, if I use this side, it has an x. We can't have two variables in a proportion and solve them. So you can only have one unknown quantity in a proportion to solve. So I'm not using this side at all right now. So, but let's look, what else do we have? How about AD? This long side, 8, so I started with 5, so I have to come back to this quadrilateral, and I'm going to use AD, which is 9. And then AD corresponds to ED in my other one, that's this one. So that's 6. So there's my proportion. Yeah, so I carefully looked at this to guide me which ones are the correct corresponding parts. All right, now let's cross multiply. Y times 9 is 9y. 5 times 6, I believe, is 30. Now that we have solved the fractions, you can solve for y by dividing both sides by 9. 30 divided by 9 is, when you use your calculator, you get 3.3 repeating, which is the same as 3 1/3. This is better. This answer is better than this one. So I'm going to box that. So this would be 3 1/3. And that's all they wanted to know is y. They did not ask for x. So when you set up your proportion, remember you cannot have two different variables in the same equation, that you won't be able to solve that. So you have to kind of look, where are numbers I can use? I used 9 and 6. You could probably also make use of the 7.5, but we didn't need it and we didn't need that. Okay, I'm gonna erase it. And on the bottom of the page, now we're looking at applications, which means how do we use this, which is always better than just the math. The math just helps us to do these applications. So using similarity, a poster design is 6 inches high by 10 inches wide. So it's a poster, okay? And what are the dimensions, or length and width, that's called dimensions, of the largest enlarged poster that will fit in a space 3 feet high by 4 feet wide? Okay, when we enlarge a drawing paper, even if we make an enlargement on our copier, it makes it on a certain scale. So all the side lengths are going to be proportional. So that's important to know. First of all, notice that our units are not the same. Units have to match. So I'm going to write that here. Units must be the same. In most cases. And if you look at the bigger unit and change it to the smaller unit, you won't have any decimals or fractions. So 3 feet, there's 12 inches per foot. So that's 3 times 12. So that's 36 inches. 4 times 12 is 48 inches. Yeah, do you see? So I'm not using feet, I'm using inches. So I like drawing me a picture. So the poster design, the design is smaller, and it's 10 by 6, right? But now we got this enlarged poster space. And it is, man, I can't even draw this good. Trying to make straight lines. It is 36 by 48. Right? So we're asking how many of these can we fit inside here? How many of these can go in here? So the thing of it is, if I go, oh, 6 goes into 36, 6 times, that means this has to be the same measurement. 6 times 10 would be 60 inches. Well, that would not fit here correctly. So we won't be able to just do 6 of these. 6 of these will not work. Because it would be too long, because that would be 60, correct? Because if I multiply 6 times 6, I get 36. That would work this way, but then 6 times 10 would be 60. We only got 48 inches, so 6 won't fit, so that won't work. Now, how many can I fit in there? 48, this is the problem, the 48 and the 10. So there would be 4 this way, because if it's 5, it would go up to 50. So let's see, 6 over 10. If my scale factor was 4, it would be 6 times 4, it would be 24 by 40. That would be the maximum, because if I do 5, scale factor 5, scale factor, by the way, is a multiplier, then I would have 6 times 5 is 30. That would fit this way. 10 times 5 is 50. That would be too big because we only have 48. Remember, this is your width, and this is the length. It's too long. So this is the minimum. So it would be the dimensions would be 24 by 40 inches. So it would be kind of like, so if this is 36, it might be like this. 24 by 40, and that all would be wasted space. So this would be the enlarged poster that would fit. Hope that makes sense to you. Okay, next page. Next page is 352. I believe we're only going to read this in the middle of the page in a scale drawing. All lengths are proportional, which means same ratio. Same ratio to the corresponding actual length. Again, corresponding is important. They have to be in the same location on the drawing, right? And this is only talking about lengths. We're not looking at angles. The scale is the ratio that compares each length to the in the drawing to the actual length in real life. Okay, the lengths used in a scale can be different units. This is important. So this is the one time you don't have to change your units. They can be different units. Okay, for example, a scale might be written as 1 centimeter to 50 kilometer, or, this is an or, 1 inch equals 10 miles, or 1 inch to 10 feet. So it's either one of these. These are 3 ways to write your scale when it's a scale drawing, okay? Scale drawing. You can use proportions to find the actual dimensions represented in a scale drawing, okay? And we're going to do that on the next page. It's in the middle of page 353, and I picked this one, architecture. You want to make a scale drawing of New York City's Empire State Building using the scale 1 inch is equal to 250 feet. So on your scale drawing, on your paper, each inch in real life, this is your drawing in real life is 250 feet. If the building is 1,250 feet tall, how tall should you make the building in your scale drawing? So the question is, how tall? I like to underline the question so not to lose sight of what it is we're doing. How tall should you make the building in your scale drawing? All right, let's see. So we have one, so you're going to write a proportion and solve. And this time we do not have to match our unit. The most important part is you keep your proportion the same, the order matters. So I decide to put my scale drawing on top. You can do it the other way. So the drawing is the top of my ratio and the real life building is the bottom. So once I just establish that order, I have to keep it the same, right? So the drawing is 1 inch for each 250 feet. And then we have how many inches for the 1,250. Okay. Remember the X is what we're looking for. How tall should you make the building? So cross product. So you always cross multiply to solve these. And that means you multiply this times that and this times that. So 1 times 1,250 is 1,250. Then comes the equal sign. 250 times x is 250x. Very simple. So now you have solved your fractions. Your fractions are gone. However, we're going to have another fraction really quick because now I have to isolate my x by dividing by 250. Use a calculator if you must, both sides. And then it says x. If you divide top 1,250 divided by 250, or you can cross cancel a common 0. 125 divided by 25 is 5. All right, we have solved it, but now let's answer the question because it's asking how tall. The building in your drawing should be, now let's use the correct measurement. What is the 5? Is that feet? Is that inches? It's in the drawing, so it should be 5 inches tall, not feet. So you go back, the drawing is in inches, correct? See how it tells me that there? This is my drawing. Okay. All right. Well, there's a way to solve your, use your scale to help you out deciding how you're going to draw it on paper. Because of course the Empire State Building does not fit on your paper. Okay. Let's go on. Do I have another? Next page is homework. So we're on page 354. Please circle the ones I give you. So so you have it on your paper. So you're starting out with, you have your similarity statement. So look at that and then complete each statement. So you're going to do number 11, angle. This is an angle. Angle D is the corresponding is angle W. How do you know? Same location. D, no wait, D is H. Same location. D and H, yeah. Now your job is to fill in, these are sides, so these are angles. And mostly we're not concerned with angles, mostly we're concerned with sides. Yeah, when we write When it's about similarity, it's about sides. The only thing we have to make sure is that the angles must be the same. I'm not going to write that here because I didn't ask for it. I just want you to know that's the only thing we have to check. Are angles the same? After that, you can forget about the angles. It's all about the sides. Okay, so you're doing 11, 12, then you're going to do 13. Look at our examples in the book. Okay, are they similar? Are these two shapes similar? Now you don't know. You got to check, right? Extended proportion. And see if ratios are equal. If they are equal, you have similar. If they're not equal, they're not similar. And then if they are similar, if they are, you got to give the scale factor. For the scale factor, either reduce fractions or divide. Okay. So those are the two things. And then you're also going to do number 14. In number 14, they're again telling you they're similar. See this little symbol? They're telling you the triangles are similar. You have to find X. Set up correct proportion. And you don't have to do the extended because they're already, the extended is only if you test. Okay. Hopefully that helps you a little bit. Okay, so that's this one. Then number 15 as well. What does the scale on the scale drawing indicate? Think about it. 355, number 16. There's an error and you have to explain it. The polygons are similar. So notice the big one on the outside and the little one on the inside are similar. So you don't have to test. They're already telling you which similarity statement is not correct. Explain. So your job is to figure out one of them is wrong and why. Okay, and then that's that on that page. The next page is the last one here. Page 356. Now here's a map. So the map is always where we have a scale factor. And here's the scale. See it? 1 centimeter on the map is in real life 112 kilometers. So this is kind of a centimeter from here to here. Okay, so to use this, you need a ruler with centimeters. All right, the Davis family is planning to drive from San Antonio to Houston. So notice from here, I like the green when it's dark background, from here to here. So you kind of have a straight shot here, right? About how far will they have to drive? So that's the actual distance. So here's how can you find the distance between the two cities on the map? You need to measure it. You do need a ruler. If you don't have one at home, come to class and use it. And then what proportion can you set up to solve the problem? Well, it's the map over real life. Okay, so you have to set up a proportion and solve, just like I showed you on the previous page. You do not have to change your units. In scale drawings, you do not have to change your units. Let's see if you can figure out the distance from here to here. Notice there's a little kink in the actual road, so we're not going to be concerned with that too much. We're just going to make it straight. Okay, and then the last one, which is probably the one that I'm most interested in, if you can figure it out and do it correctly, find the value of x. So you have to figure out what x is, okay? And then give the scale factor. So x is equal to what? And what's the scale factor? So this is already telling you they're similar. Do you see that? This is similar to that. And you can just match up the sides by picking the correct letters, how they're located. Okay, 2 questions. Good luck to you. This is it for your homework. Try your very best.